Good morning. Today we're going to talk a little bit about acids, bases, and their interactions with one another. This is all we're going to really do with Chapter 18. I'm not going to go into the math of Chapter 18, but we do have to go into a little bit about what is an acid and what is a base. A couple of basic properties of acids and bases. Acids are sour, they feel clean. They're an electrolyte, meaning they will conduct electricity. They'll turn litmus paper red and phenolphthalein clear. And in a reaction, when a acid reacts with a metal, it's going to form hydrogen gas and whatever the salt is with that metal. And when it reacts with a base, it's going to form salt and water. A base is going to be bitter. It's going to feel slippery, like soap. It's an electrolyte. It turns litmus paper blue and phenolphthalein pink. And when a base reacts with an acid, it's the exact same reaction. It's going to get salt and water. When acids and bases combine, they form neutralization reactions. Okay? An example of an acid with a metal would be, oops, that's huge. If I have HCl, and I add magnesium, I'm going to get magnesium chloride and hydrogen gas. Whereas in a neutralization reaction, if I take that same hydrochloric acid and I add it to sodium hydroxide, I'm going to get NaCl and H2O. HCl and NaOH by themselves are pretty dangerous substances. You don't want to mess with either of them. But yet if I combine the two, I basically just get salt and water, or salt water. Now keep in mind that NaCl is actual like table salt, but anytime I have an acid together, like if I had Hi plus MgOH2, this would yield MgI2 and H2O. And now magnesium iodide isn't table salt, but we would call that a salt. So anytime you have the positive ion from your base and the negative ion from your acid coming together, they're going to consider that a salt. Okay? A couple of things about acids that you should know. There's a couple different definitions of acids. There's the traditional or the Arrhenius acid and base. There's a Bronsted-Lowry acid and base. We're going to skip all that, unfortunately. And we are just going to focus on the traditional or the Arrhenius acid. And one thing you'll notice with all those acids is they all have hydrogen as their positive ion. Okay? That hydrogen as a positive ion is going to tell you that that's an acid. And you'll notice that that hydrogen is always going to be the first ion listed. It is the cation. For the bases, what you're going to notice is that they're all going to have hydroxide as their anion. Okay, your hydroxide is going to indicate a base. Now, when you take that positive hydrogen from an acid and that negative anion from a base and you put it together, you get HOH, which we all know is water. Okay, H2O. Skipping all this. A couple of things to know about acids. There's three different kinds. There's monoprotic acid, diprotic acid, and triprotic acid. And a monoprotic acid, mono meaning one, just means that there is one hydrogen. A diprotic acid means there are two, and a triprotic means that there are three. It's nothing more than that. Mono 1, di 2, tri is 3. The number of acids that an acid has does not indicate the strength of the acid. That's important that you realize. What really indicates the strength of the acid is how completely it dissociates or splits up when you add it to water. Okay? When you put an acid in water, the hydrogen and the hydroxide, the hydrogen from the acid breaks up and adds itself to water. That creates what is called the hydronium ion, H3O+. Okay? All of your acids are aqueous solutions, meaning they're dissolved in water. So this hydronium ion is created when the H plus is in the presence of the water. The H plus from the acid is very attracted to the negative end of the water molecule. So when I take hydrochloric acid and I add it to water, I don't get just H plus and Cl minus. What I actually get is HCl plus H2O yielding H3O plus and chloride in the chloride ion. The concentration of that hydronium ion will determine the strength of the acid. The more concentrated that hydronium ion is, the stronger the acid. The more easily those ions split, the stronger the acid. So hydrochloric acid is a strong acid. When you take hydrochloric acid and you add it to water, every hydrochloric acid splits. Okay, every molecule splits into the hydronium ion and the chloride ion. If you take a weaker acid like sulfuric acid, H2SO4, and you add that to water, you're going to get some hydronium ions. You're going to get some HSO4 minus ions. You're going to get some SO4 2 minus ions. You're going to have a bunch of different ions floating around in this solution. It's not going to be as strong as a solution of hydrochloric acid. So in your strong acids, they're going to dissociate completely. So strong acids will readily transfer H plus to water to form H3O plus. This is a strong electrolyte, meaning it will conduct electricity easily. A weak acid does not readily transfer the H plus to water. It forms a weak electrolyte. Now notice in the two examples I just gave, I actually have them written down here. And what you'll notice is that when I have a weak acid, it is a double arrow, meaning it is a reversible reaction. And we know that all of these ions are going to be found in some concentration. Okay? Whereas in the strong acid, it's a single arrow. In the single arrow, I am only going to have the H3O plus and the Cl minus ions. Whereas in the weak acid, I'm going to have all of these ions present. Okay? And that goes back to what we were talking about in the last unit, chapter 16, I believe, when we were doing concentrations. And we're going to be doing some of that with acids and bases. So that's pretty much it for chapter 18 that I want to cover. I'll have a quick discussion on Schoology today for you to answer after watching this. So please be looking for that. Have a great day.